Hello guys, so today we are here to solve our daily lead code challenge for the day, and this challenge is find the student that will replace the chalk. In this challenge we are given n number of students, okay, and these students are in a class and they are numbered from 0 to n minus 1, the array ordering, okay. The teacher will give each student a problem starting with the student number 0 and then the student number 1 and so on until the teacher reaches the student number n minus 1. So problem will be there and each student has to solve it. Okay. And after that, the teacher will restart the process. So he will again come back to the student number 0. Okay. And you are given a zero indexed array chalk and an integer k. They are initially k pieces of chalk. So at first, we are given k pieces of chalk. So this k pieces of chalk is there that is given at first. Okay. And each ith student will be using the ith index of the chalk array. Okay. So that ith index of the chalk array contains the number of chalks used by the ith student. Okay. Now it is mentioned that if the current number of chalk pieces is strictly less than chalk I, okay, so after using, chalks, if k at any point of time is becoming strictly less than the chalk I value, ith value of chalk array, then the student I will be asked to replace the chalk. Okay, return the index of the student that will replace the chalk pieces. So this is the problem that we have to solve it. So in order to solve it, what are the things that will be, using it? First of all, we'll be taking the, chalk dot length. First of all, we'll be using this. Then what we will be doing that, we will be using a long sum is equal to 0 L. Okay. And then uh, we can, loop through the values of the chalk. So in order to loop through the value of the chalks, we'll be, using this for each loop, and sum plus is equal to I will be doing. And after this, what we will be doing that will be, getting into a mm, if else thing. Okay. And in if else, what we'll be doing, if sum is equal to k, then we'll be returning 0. Okay. Why we'll be returning 0? Because if sum is equal to k, then till the time the last student uses the chalk, after that it will become 0. And when it again comes back to the first student, which is index 0, that value will be strictly less than the chalk I. The chalk 0 value will be strictly greater than the k. So we can return safely. Else, else if sum is greater than sum is less than k. So if sum is less than k, then in that case, what does it do? If sum is less than k, it means the total content of the chalk array is less than k. So the available chalks are much more. So we can do many rounds. So if we can do many rounds, then to get the value, we'll have to do this k percent sum. Okay. And if after doing this k is equal to 0, uh, k becomes 0, then again we'll be returning 0. Okay. Otherwise, what we will do that we will initiate a loop. Okay. Int I is equal to 0, I less than n, because n is the length of the chalk array, and plus plus I we will do. And then what we will do, if what we will do, uh, so we will do if k is less than chalk of I, then we will return I. Okay, otherwise what we'll do, k minus is equal to chalk of I will do like this. Okay, and then in the else part, because now sum is less than k is done, then what is remaining is sum is greater than k. So if sum is greater than k, then only within one loop we'll be able to get the answer to this problem. Okay, we don't have to do too many loops, too many iteration of the loop. So within one loop, we'll be able to get the answer. And now what we will do, so this will take care of that situation also. And at the end, what we'll do, we'll return -1. Okay. So let's see whether this solution works or not. This is accepting. Okay, we'll submit this. Perfect. So this solution is working. Uh, let me know if there is any doubt. Please, please post your doubts in the comments and I'll happily answer those doubts. With this, I'm thanking you one and all. Best wishes, happy coding.